Hello guys, I hope you are doing well. Today I wanted us to discuss about the pathogen causing gonorrhea. That is part 2. In part 1, I introduced you on to what gonorrhea is and we discussed few issues to do with the introduction to gonorrhea. Now, today we are going to discuss about the pathogen causing gonorrhea. Now, this pathogen causing gonorrhea, it belongs to a genus called Neisseria, which has two medically important species. Species number one is Neisseria gonorrhoeae, which causes gonorrhea. Species number two is Neisseria meningitidis, which causes meningitis, which is bacterial meningitis. Now, we are going to go into deep details about Neisseria gonorrhoeae. Neisseria gonorrhoeae is a non-motile, non-spore-forming gram-negative coccus. That's a gram-negative bacteria. Now, this bacteria grows in pairs. It grows in pairs called diplococci, whereby the adjacent sides of two pairs of bacteria, they are flattened to look like a coffee bean. That's the reason why we say it is a coffee bean shaped. Also, Neisseria gonorrhoeae resembles what we call Neisseria meningitidis, which causes meningitis. Also, it looks also like other several species of Neisseria genus, which are non-pathogenic in nature. That is, those species of Neisseria genus which do not cause human illness. Now, all all Neisseria species, they do oxidize. They do oxidize. These chemicals: one, dimethyl paraphenylenediamine and tetramethyl paraphenylenediamine. This oxidation forms basis for a test we call oxidase test, and it is positive for Neisseria organisms. Now, in older ages, that is traditionally, gonococci, these are bacteria which cause gonorrhea, they were differentiated from other Neisseria species by their ability to grow on what we call selective media. This selective media is that kind of a special media which allow growth of preferred organism, then inhibit growth of other organisms. Neisseria gonorrhoeae can only use glucose but cannot use maltose, it cannot use sucrose, it cannot use lactose. The reason behind is because this Neisseria gonorrhoeae, it does not produce maltase enzyme which metabolizes maltose. It does not produce sucrase enzyme which metabolizes sucrose. It does not produce also lactase enzyme which metabolizes lactose. Organisms, when they grow in a media, they do reduce nitrates. They do reduce nitrates because nitrates acts as an electron acceptor for these organisms. These organisms, they do have an inability to grow at a reduced temperatures, and also they have inability to grow in just a simple nutrient agar. Simple nutrient agar is the one which does not inhibit growth of many organisms, and just a symbol, it's just a nutrient only. It has not added it does not contain other chemicals which are added into it. As you can see, all strains of Neisseria gonorrhoeae, they are anaerobic, meaning that they do grow in an area where there is oxygen. But since they reduce nitrate, when nitrate is added in a media and then they are incubated anaerobically, they do grow. The reason behind it is nitrate acts as an electron acceptor for these organisms. Also, another point to note about Neisseria gonorrhoeae is that they grow at a temperature that is 35 to 37 degrees Celsius. And to increase their growth, you are supposed to have 5% of carbon dioxide. So as you incubate, your incubator must be set at 37 to 35 to 37 degrees Celsius. Gonococci, they are very prone to drying. So guys, when you have samples from patients, they should be inoculated immediately to avoid drying so that these organisms can grow. Also, when you want to transport these samples from patients to very far places, they should be stored immediately in appropriate transport media so that we can avoid drying of these samples. So guys, that is end of our lecture today, and these are important concepts which you are supposed to understand about gonorrhea. So guys, let's meet at part 3 so that we can understand what virulence factors make these organisms to be able to penetrate our cells and cause disease. So guys, I love you. Goodbye.